Nothing in the universe is allowed to outrun light. Not rockets, not particles, not even information. That sounds like a rule, but what if it's not a rule at all? What if space and time themselves simply break? If you try, what if going faster doesn't just make you late, but makes cause happen after effect? If that's true, the speed of light isn't the limit. It's a warning.
Outline 1.
Space-time's secret hiding speed limit. Imagine you're trying to send a message across the universe. You don't care how. Flash a light, shout really loudly, throw something. Use the most powerful rocket ever built. Whatever you choose, there's a strange rule waiting for you. Nothing gets the message there faster than light. At first, this sounds like a law someone wrote down, like a cosmic speed sign saying maximum speed light only. But the universe doesn't work that way. It doesn't post rules. It builds them into how things are allowed to happen. So let's slow down and ask a dangerous question. What is speed? Really? Speed is distance divided by time. That sounds simple, but it hides a secret. To talk about speed, you must agree on distance and time. You must decide what here, there, now, and later mean. And that's where things get strange. Imagine two events. A flash happens here. A bell rings over there. Which one happens first? You might think that's obvious. But it depends on how you're moving. If you're standing still, you see one order. If you're racing past at high speed, you can see a different order. The universe allows that. Time is flexible. Now here's the shocking part. There is one thing everyone agrees on. No matter how fast you're moving, no matter which direction, no matter how you chase it, light always moves at the same speed. That sounds impossible. If you run toward a ball, the ball seems faster. If you run away, it seems slower. But light refuses to play that game. Everyone measures the same speed, so something has to give. And it's not the light. Space and time bend instead. Distances shrink. Time stretches. Clocks tick differently. Rulers change length. All of this happens just to protect one simple fact. Light keeps its speed. This tells us something profound. The speed of light is not just about light. It's about the structure of space and time themselves. It's the glue holding them together. Think of space and time as a fabric. Not cloth that you can touch, but a rule book the universe follows. That fabric has a built-in conversion rate between space and time. A certain amount of distance equals a certain amount of time. Light moves exactly along that exchange rate. Nothing can go faster because there's no faster to go to. If something tried, it wouldn't just break a speed limit. It would break cause and effect. Cause and effect is the idea that causes come before results. You flip a switch, then the light turns on. Simple. But if information could travel faster than light, some observers would see the effect happen before the cause. That's not just confusing. That's a disaster. Imagine sending a message that arrives before it was sent. Someone could reply before you even decide to send it. The universe would have to explain how effects exist without causes. It refuses to do that. So instead, the universe says, no signal, no object, no information can outrun light. Not because light is special as a thing, but because space-time is special as a system. Even massive objects feel this rule. The more energy you give them, the harder it is to speed them up. It's like pushing against an invisible wall. As you approach light speed, time slows down more and more. Distance is squeezed tighter and tighter, and the energy cost shoots toward infinity. You're not being blocked by a barrier. You're running out of ways to move through space and time. Light doesn't experience time at all. From its perspective, if you could call it that, emission and arrival are the same moment. That's why it always moves at the same speed. It lives right on the edge of space-time's rules. So the speed of light is not the fastest thing in the universe. It's the shape of the universe. It tells us how space turns into time, how motion reshapes reality, and how cause protects itself from chaos. Once you see that, the speed limit stops feeling arbitrary. It feels inevitable. And the real question changes from why can't we go faster than light to something much deeper. What kind of universe makes light the ruler of time itself? Outline 2. Light speed built into reality. Let's start with something that sounds obvious, but isn't. Light has a speed. Not just any speed, but a very specific one. And no matter who measures it or how fast they are moving, they always get the same answer. That alone should make you uncomfortable. Because in everyday life, speeds add and subtract. If you run toward a moving train, the train seems faster. If you run away, it seems slower. That's how the world usually works. So when light refuses to follow this rule, the universe is quietly telling us something important. At first, people thought the speed was just a property of light itself, like weight is a property of rocks, or color is a property of paint. But that idea doesn't survive very long, because when you try to change how fast light moves by chasing it, or running away from it, or measuring it in different ways, it stubbornly stays the same. So the mystery shifts. Maybe the speed of light is not about light. Maybe it's about reality. To see why, think about how we measure anything at all. We use rulers for space. We use clocks for time. Speed is just a comparison between the two, how much space changes during a certain amount of time. Now imagine the universe has decided on a fixed exchange rate between space and time, like a cosmic conversion factor. So many meters for so many seconds. That number turns out to be the speed of light. This means light is not choosing its speed. It is revealing the speed built into the universe itself. When something moves, it doesn't just travel through space. It also travels through time. You can't stop doing either. Even if you're sitting perfectly still in space, you're still moving through time. And the total motion through space-time is always the same. Light uses all of that motion to move through space. Massive objects use some of it to move through space, and the rest to move through time. That's why they can't reach light speed. They can't shift all their motion into space without giving up time entirely. As objects move faster, strange things begin to happen. Clocks slow down. Lengths shrink. Not because something is broken, but because space and time are adjusting to protect that built-in speed. This is not an illusion. It's not a trick of measurement. Two clocks really can disagree about how much time has passed. Two rulers really can disagree about length. The universe allows these disagreements because it cares more about preserving the speed of light than about preserving our common sense. Now here's where it gets deeper. The speed of light is also the speed of information. It's the fastest way because it can influence effect. It defines what can possibly affect what else. If something is too far away and not enough time has passed, it simply cannot matter to you yet. This creates a structure in reality, a kind of invisible boundary around every event. Inside this boundary, causes and effects can connect. Outside it, they can't. The structure exists everywhere, all the time, whether light is present or not. So even in complete darkness, the speed of light still rules. That's why gravity follows the speed too. Changes in gravity don't happen instantly. They travel at the same universal limit. The universe refuses to allow any influence to break this rule. Why? Because if it did, cause and effect would fall apart. If information could travel faster than light, some observers would see effects happen before causes. Messages could arrive before they were sent. The idea of before and after would stop making sense. So instead, reality bends space and time to keep order. The speed of light is not the fastest thing in the universe. It is the deepest rule the universe knows how to keep. It tells space how to behave. It tells time how to flow. It tells matter how fast it's allowed to change the world around it. And once you see that, light speed stops feeling like a limitation. It feels like a signature, a number written into the foundation of reality itself, quietly holding everything together, whether we notice it or not. Outline 3. Nothing faster, because time breaks. Imagine you are trying to win a race against light. You build a faster engine. You add more fuel. You push harder and harder. At first it feels like a normal problem. Just go faster. But then very strange happens. The problem stops being about speed at all. It becomes about time. We usually think of time as a steady river. 1 second follows another. Everyone agrees on what now means, but that comfortable idea works only when speeds are slow. The moment you start chasing light, time stops behaving like a simple background. Let's start with something familiar. Two people have clocks. They set them to the same time. One stays still. The other moves very fast, almost as fast as light, and then comes back. When they compare clocks again, they don't match. The moving clock is behind. Less time passed for it. This is not because the clock is broken. It's because time itself slowed down for the moving object. The faster you move through space, the slower you move through time. That sounds poetic, but it's literal physics. There is a trade-off. Motion through space steals motion from time. Now imagine pushing this idea further and further. You keep accelerating. You get closer and closer to light speed. What happens to time? It slows down more and more. As you approach the speed of light, time for you approaches zero. From the outside, you almost freeze. From your own point of view, the universe outside races ahead. Now here's the key idea. To go faster than light, time would have to go backward. Because once time reaches zero, there is no more time left to slow down. You can't have negative time without breaking cause and effect. You would start seeing results before causes. Think about sending a signal faster than light. In some frames of motion, that signal would arrive before it was sent. Someone could receive a message, reply to it, and send a reply back before the original message was even written. That's not science fiction. That's what the equations say. The universe does not allow this, not because it's polite, but because reality would lose its order. Events would no longer have a clear sequence. The idea of before and after would depend on who is watching in a way that creates contradictions. So instead of allowing faster than light travel, the universe puts up a different kind of barrier. It lets time bend, slow, stretch, and twist, but it never lets it flip. Light sits right on the edge of this rule. For light, time does not pass at all. From emission to absorption, there is no ticking clock. That's why light always moves at the same speed. It uses all its motion to move through space and none to move through time. Anything with mass is different. It must move through time. It cannot stop. And because it must spend some of its motion on time, it cannot spend all of it on space. That's why it can never catch light. As you push a massive object faster, it resists more and more. Not because space is pushing back, but because time is. You are trying to squeeze time thinner and thinner, and it refuses to vanish. Energy requirements explode. You can add energy forever and still never cross the line. The closer you get, the more the universe demands. So the speed limit is not about engines or fuel or technology. It's about time protecting itself. If you could break the light barrier, you wouldn't just go fast. You would shatter the sequence of events. You would mix up causes and effects. You would turn reality into a puzzle with no solution. So the universe chooses a simpler rule. Nothing goes faster than light, because if it did, time itself would break. And once you see that, the speed of light no longer feels like an annoying limit.
It feels like a safety feature.
A deep, quiet rule that keeps the story of the universe making sense, one moment after another. Outline 4. Speed limit from cause and effect. Think about the simplest idea you know. One thing happens, and then another thing happens because of it. You flip a switch, the light turns on. You let go of a ball, it falls. Cause first to effect and later. This idea feels so basic that we almost never question it. But the universe guards this idea very carefully. Now imagine you want to send a message. It doesn't matter how light, radio waves, gravity, particles, anything. You want something that happens here to affect something over there. That influence must travel. And the universe allows it to travel only so fast. Why? Because if it didn't, cause and effect would stop making sense. Let's see how that happens. Suppose you had a magic signal that could travel faster than light. You send a message to a distant friend. In your frame of motion, you send it first, and they receive it. All good. But motion changes how time works. If your friend is moving relative to you, their clock does not tick the same way as yours. Events that look ordered to you can look reordered to them. With a fast enough signal, something strange appears in your friend's frame. The message can arrive before you sent it. That sounds impossible, but it's not a trick. It falls straight out of how space and time behave. When speeds are high, before and after are no longer universal. They depend on motion. Now push this one step further. If your friend can reply using the same faster-than-light signal, they can send a response back to you before you ever decided to send the original message. You would receive an answer to a question you haven't asked yet. At that point, the idea of cause collapses. Effects exist without causes. Decisions happen after their consequences. Reality becomes a loop with no clear starting point. The universe refuses to allow this. So instead of letting signals move arbitrarily fast, it builds in a strict limit, a maximum speed at which any influence can travel. That speed is the speed of light. Light is not special because it's bright or fast. It's special because it sits exactly on the boundary between what can cause what. Inside this boundary, events can influence each other. Outside it, they can't. No matter how powerful the cause, no matter how sensitive the effect, the influence simply hasn't had time to get there yet. This boundary exists even when there is no light at all, in empty space, in darkness. It's part of space-time itself. This is why gravity doesn't act instantly. When the sun moves, Earth doesn't feel the change right away. The information about that change travels at light speed. If it were faster, gravity could break causality too. Everything that carries information follows the same rule. Now here's the clever part. Instead of saying nothing can go faster than light, the universe says something deeper. It says no effect can happen before its cause. And the speed of light is just a mathematical expression of that rule. Space and time adjust themselves to make sure it holds. Clocks slow down. Length contract. Different observers disagree about the timing of events. All of this bending happens so that causality survives. It's not that faster speeds are forbidden by a sign. They are forbidden because they would tear the logic of the universe apart. So when you try to imagine faster than light travel, you're not just imagining a better spaceship. You're imagining a universe where answers arrive before questions, where messages write themselves, where the order of events depends in a self-contradictory way. Our universe doesn't choose that option. It chooses consistency. It chooses a world where causes lead to effects, where stories have beginnings before endings, where time still points forward, no matter how fast you move. And the speed of light is the quiet enforcer of that choice. Not a wall, not a limit we bump into, but a deep rule that keeps reality from arguing with itself. Outline 5. Light reveals universe's hidden clock. Let's try a strange idea. What if the universe has a clock? Not a giant ticking machine somewhere in space, but a hidden rhythm that tells everything when now as we usually assume such a clock exists. We feel time passing, seconds tick by. Surely the universe agrees on the moment, but it doesn't. Time turns out to be personal. Here's where light enters the story. Light doesn't just show us things. It tells us how time itself is allowed to work. Imagine two people far apart. They want to agree on what now means. One flashes a light, the other sees it later. Already there's a problem. The information about now travels at a speed. That speed is not infinite. It's the speed of light. This means there is no universal now that everyone shares. There are only local clocks, connected by light signals. Light becomes the messenger that stitches time together. Now here's the shocking part. No matter how fast you move, light always moves at the same speed relative to you. You can chase it, but it never pulls away faster. You can run from it, but it never slows down. So the universe makes a deal. If light must keep the same speed for everyone, then time itself must adjust. Clocks in motion slow down, not because they malfunction, but because time is stretching. If two clocks move differently, they genuinely experience different amounts of time. This means time is not flowing from a single cosmic clock. It's being measured locally, moment by moment, using light as the ruler. Light doesn't just travel through time. It defines it. There's an even deeper layer. For light, time does not pass at all. From emission to absorption, there is no ticking. If you could ride along with a beam of light, the entire universe would collapse into a single instant. That sounds impossible, but it's exactly why light behaves the way it does. Because light doesn't experience time, it always moves at the same speed. It lives at the boundary between space and time. It shows us where time ends. Everything else, with mass, must experience time. It must age. It must change. And because it must move through time, it cannot move as fast as light through space. So light reveals a hidden structure. There is a maximum rate at which the universe allows change to propagate. That rate is not about speed in space alone. It's about how fast now can move from one place to another. This is the universe's hidden clock. Not a single ticking sound, but a rule that says how fast moments can spread. When something happens, that moment expands outward at light speed. Outside that expanding boundary, the event hasn't happened yet. Not really. It cannot influence anything there. So every event carries its own clock, and light is what synchronizes them as much as possible. This is why faster than light travel causes trouble. It's not just moving fast. It's trying to skip ahead of time's own accounting system. It's trying to arrive before the universe has finished counting the seconds. If that were allowed, time would lose its meaning. Before and after would blur. Effects could appear without causes. So the universe protects its hidden clock by enforcing a simple rule. Nothing outruns light. Light is not the fastest traveler because it wins a race. It's the fastest because it defines what a moment is. It tells the universe how to order events, how to connect causes to effects, how to let time exist at all. And once you see that, light stops being just illumination. It becomes the heartbeat of reality itself.